Hello all. Make sure that you have taken the time before we get started to either print out the guided notes for quadratic functions or that you've set this up in your own notebook. Here we have the homework for tonight from chapter 12, section 7. Remember, you can pause, you can turn on closed captioning, subtitles if you like. Leave any questions that you have in the comments below. So let's get started. So, as we would normally start here, if I say the objective is to solve and graph with quadratic functions, we're going to want to start off by defining what that word quadratic means. A quadratic function has to have an x squared term, meaning that it's going to have, maybe 10x squared or negative 2x squared. Has to have this, and it may have an x term and a constant term. As I said, these two are optional, so either the x term or the constant term may equal 0. So an example of this might be something like 2x squared minus 5x plus 1, where we've got our x squared term showing that it's quadratic. And we have an x term and a 1 here. This is a lovely quadratic example, but it would be just fine if, let's say, this constant term of 1 was equal to 0. That's still a quadratic. Just like with lines, with linear functions, quadratic functions have different forms. So if you remember with lines, we had slope-intercept form, we had point-slope form. Here we have two different forms as well. We have standard form, which this example is in standard form. So I had to erase there to make space. Obviously, you don't need to do that. Just keep writing. So in standard form, we have all the terms just written out. So we have our function is equal to something times x squared plus something times x plus our constant. So you can see that this is just like how our example, in that a is 2, b is negative 5, and in our example c is 1. So a, b, and c are numbers. And then, like I said, it's fine if b or c is equal to 0. A can't equal 0 because then there's no x squared term. That's what makes a quadratic special. If a was 0, then it would be a line because there would just be an x term. But b and c could be 0. So this is what standard form looks like. What you might notice here in number 1 is that this is not in standard form here. That's the first goal that we're going to have. This is called factored form. Now, factored form, like you would hopefully maybe deduce some of you, in factored form we're talking about factors, meaning multiplication. So these are two factors multiplied by each other, and we end up with the factored form is going to have an x in the front of two sets of parentheses, and then plus some r, some s. So as you can see here in the example, we've got our r is plus 3, here is minus 1. So r and s are numbers, and just like in standard form, they can equal 0. Obviously they're not always going to, but it's just fine if they do. So there's the vocabulary. These are our two separate forms for our quadratic functions. Let's talk about some of the problems and how to use them. So we have factored form here, and we want to put it into standard form. Now, what you would hopefully see is that this looks kind of like a distribution problem, and that's exactly how we're going to solve it. But instead of having one number over here, we have 2. So we have to distribute both. And the mnemonic that a lot of teachers will use for this is FOIL. So they'll tell you to FOIL something. And FOIL just helps you remember to distribute every single term. So the F stands for first, meaning that we multiply the first term here and the first term here. So that's our first distribution. And the O in FOIL stands for outer, meaning that we're going to distribute the outside here to the outside here. So these two are on the outside of the whole problem. So in this case, x times negative 1. The I in FOIL stands for inner, meaning the two terms on the inside. So now we're going to start distributing that 3. And so that's going to be 3 times x. Run out of space a little bit, I'm just going to scoot those over. And finally, the L stands for last, so the last number in each term. So 3 is the last here, -1 is the last here. And so then our last term is going to be 3 times -1. So FOIL is a helpful mnemonic, but as you can see, what we did is just distribution. We distributed the x first to both of these, and then the 3, and now we have these terms here, and just like in the distributive property, we are going to add them all together and simplify. So x times x, we're going to write as x squared, that's how we know it's quadratic, plus x times -1, which will simplify as -x, plus 3 times x, 3x, plus 3 times -1, which is -3. So you can see here we've got a quadratic, we have our x squared term, we have 2 x terms here, which we are going to simplify because they are like terms. They don't have an exponent, but they do both have the variable x. So -1 plus 3, x squared plus 2x, minus 3, and here we are in standard form. So that's how we go from factored form to standard form. Of course, there is a way to go from factored from standard to factored, but it's more complicated, and we're going to leave that for either later in this year or perhaps even you'll definitely see it next year for sure. With quadratic functions, we're also going to add in not just y-intercepts, which you're used to from a slope-intercept form, the plus b, we're also going to add in x-intercepts, which is where the graph crosses the x-axis. And the nice thing about these is that you're going to use the 2 separate forms that we have here that are going to make one easier than the other. So let's start with the x-intercept since that's new. For the x-intercepts, you're going to want to use factored form. So we're going to use factored form here. We're going to use the f of x from question 1. Here's the factored form. It's the one at the beginning of the question. And x-intercepts are when they're on the x-axis, so the y is 0. Now remember, y is the same as f of x, so we can take that away and just write in 0. So this is the equation we're going to solve, which seems a kind of an odd equation. But the nice thing is this is why it's nice in factored form, is that if I have 2 things that are being multiplied together to equal 0, one of them has to equal 0. Right? It's either 0 times 7 equals 0 or 0 times 3. One of these 2 numbers has to be 0 in order for this multiplication problem to work. So with parabolas, with quadratic graphs, you actually end up with 2 x-intercepts a lot of the time. Not always, but a lot. And you can think about them as 2 separate problems, because either that first factor equals 0, or the second one equals 0, and now you have 2 very simple equations to solve. Subtract 3. So the first x-intercept is at x equals -3, and the second one is at x equals +1, because you added 1 here on both sides. So there's 2 of them, and we will see what that looks like in the graph in number 3. But now that we found our 2 x-intercepts, we want to find our y-intercept. As you can imagine, since I said we were going to use both forms, if we're using factored form for our x-intercepts, we're going to use standard form for our y-intercept. And yes, there's just one of those. So I'm using standard form here from our answer to the last problem. And now, just like in our lines, the constant term is your y-intercept. So remember it was mx plus b. That number at the end was the y-intercept. It's the same thing here. So you can just take that constant. If you want proof of why this works, it means that x is equal to 0. So when I plug in 0 to our function, we get 0 squared plus 2 times 0 minus 3, which is 0 plus 0 minus 3, which is -3. But mostly what students will do is just, no matter what kind of graph we're looking at, the constant term will usually be the y-intercept. There are a couple where this isn't true, but none of the ones where it's x will this be true? That's going to be your y-intercept. So let's talk about how to graph with our 2 x-intercepts and our 1 y-intercept. So we've mentioned this type of graph before, but a quadratic graph is called a parabola. And it looks sort of like a big U if it's a positive one, but we can definitely have negative parabolas where they are going down like this. It looks more like a frown. 2 important characteristics about a parabola. It has a vertical line of symmetry down the center. So my drawing isn't perfect, but the graphs will make that a little bit easier. And at the bottom or at the top, depending if it's negative, of our parabola, we're going to have a point right on the line of symmetry. And this is called the vertex, just like the part of an angle where it turns. And this is sort of at the point at the bottom or the top of the parabola. So in our graph, we're going to start with our intercepts. We had our y-intercepts at -3, and we had an x-intercept also at -3 and at x equals 1. So those are the 3 points I'm going to put on first. On the x-axis for our x-intercepts at -3, we have our first one right here. And then we have one at +1 on the x-axis. And then we have a y-intercept on the y-axis here at -3. So right there. So this kind of is giving us a little bit of a parabola shape, but as you can see, that would not be symmetrical. So what we're going to do is I'm just going to pick a couple points in between here at these 2 x values to give us more of a symmetric curve like this. So, and those x values in between are at -2 and -1. And we can use that just by plugging in to either of the standard or factored form. If we plug in -2, you end up with -3. If you plug in -1, you end up with -4. And so that gives us 2 more coordinate points like that we can put on our graph. And now you see we have a much more symmetrical parabola, which we can draw in like this. So what I like to do is I like to start at the bottom at the vertex, and then I draw up and here with an arrow, and then I'll go back to the bottom and try to draw as symmetrically as possible on the other side, passing through all the points. One thing I want to make sure that you're doing is make sure that you're giving it a nice curve at the bottom, and that you're not drawing it like a really pointy V. That's not what a parabola looks like. It's got a good bend to it. Just make sure you're going through all the points as best you can. So, please let me know if you have any questions about graphing quadratics, about putting things into standard form, about finding intercepts, and I'll be available on Google Classroom or on Zoom or by email. Have a wonderful day, and I look forward to hearing from you.